everyone, I am Sneha, co-founder and CEO DevCompass, and I am a little extra thrilled today because we have reached the final video of stage 3, and that means you have one more capstone project coming up. So I hope you're all ready, all prepared, you know all the concepts well. And yeah, this one is going to be a super interesting session. The one last topic that we talk about when we discuss multi-agents in detail. For everyone who doesn't know what I'm talking about, please head over to devcompass.ai and you will get all the relevant information. If not, please write to us and we are always happy to help. Okay, so in the last video, we did talk about failures. And what happens when you come back to like a very long running multi-agent session, how do you deal with that, blah blah blah. So that's what this video is going to be about. So multi-agent tasks can run for a long time. A research pipeline that queries multiple data sources, synthesizes findings and drafts a report might run for minutes if it gets interrupted. A timeout, a crash, a deliberate pause for human review. You have a decision to make when you come back to it. Do you resume where it left off? Do you fork the session and take it in a different direction? Or do you start completely fresh? Each of these is the right answer in a specific situation, and choosing the wrong one wastes time, corrupts state, or produces results that you can't trust. So this video gives you the framework for making that call. Let's get started. Okay, so 3 options clearly before we talk about when to use each. First, resume. You have a session that was paused either deliberately for a human review step or because of an interruption. The session state is intact. The conversation history is intact. The work that was completed before the pause is still there. You call Claude resume with the session ID and the agent continues from exactly where it left off. Simple. It sees everything that happened before, it knows what it found and what tasks it completed and what is still pending. Second, fork. You take an existing session as a starting point and create a branch from it. The fork inherits the history up to the fork point. Everything the original session discovered and decided, but from the fork point forward, the 2 sessions are now independent. Charges in the fork don't affect the Changes in the fork don't affect the original. This is like making a copy of a document and editing that copy. The original is preserved as it is. You use fork session with the session ID to create it. Third, start fresh. Clean slate, new session ID, empty context, no history from the previous session. You pass in whatever context the new session needs manually. Relevant findings, original query, whatever the agent needs to do its job, everything else is gone. 3 options, 3 different relationships to previous session states. The question is which one to use, and that depends on why the session ended and what you need to happen next. Okay, now the decision framework. So I'm going to walk through each of the branch in this flow chart. Let's start from the top. Why did the session end? 3 scenarios. First, deliberate pause for human review. Someone stopped the session to look at what the agent found and decide whether to continue. If the review approved the work so far and you want to continue in the same direction, resume. The work is good, the context is intact, pick up where you left off. If the review identified a problem with the direction, the agent was going down a wrong path or the scope needs to change, it's time for you to fork. You keep the good work that was done before the branch point, but you change direction from here. Second, timeout or crash. The session was interrupted unexpectedly. Network timeout, process crash, infrastructure failure. First question, is the session state actually intact? If the session state was saved before the crash and is reliable, Then resume carefully. Check what state the agent was in when it crashed. Was it mid-tool call? Was it part way through a synthesis? Resume from a known good checkpoint, not from an ambiguous mid-step step. If the session state is unreliable or corrupted, start fresh. Don't try to resume from a broken state. The risk of propagating corrupted context through the rest of the task is higher than the cost of starting over. Third, the session is stale. It's been so long since the session ran that data. It collected may no longer be valid. Policies may have changed, customer records may have been updated, prices may have shifted. If the staleness risk is high, start fresh and recollect the data. If the data is unlikely to have changed and the session history is still valid, resume. Now, let's make this a little more concrete with real life scenarios, each one with a different answer. Scenario 1. A research pipeline was running and hit a human review checkpoint. The coordinator paused and surfaced its findings. A human reviewed the findings and approved them. This task should continue in the same direction with the same coordinator. What should be the decision? Answer is resume. The session is intact. The direction is approved. The work so far is valid. Resuming with resume flag picks up from exactly the pause point. Scenario 2. Same research pipeline. It found good data in the first half, but during review the human noticed that the coordinator was pursuing a line of inquiry that's actually outside the scope of the original question. It got sidetracked. The first half of the work is valid and useful, but the second half needs to go in a different direction. What should be your answer? Fork. Fork the session at the point before the misguided work started. The fork inherits all the valid findings. The original is preserved in case you need to refer back to it. The fork takes the corrected direction. Scenario 3. The pipeline ran like 3 weeks ago and then you went on a vacation and collected data about product pricing and return policies. You want to run a similar analysis now, but product pricing changes frequently and the return policy was updated 2 weeks ago. Answer: start fresh. The data the session collected is no longer valid. Resuming from it would be resuming from stale information. Start fresh, pass the original query and let the agent recollect the current data. Now, in this one, the final thing that I would really like to cover, and it's a detail that trips up all developers writing coordinator prompts for long running tasks. So, the coordinator that doesn't export its state, it runs, it finds things, it builds up a picture of the problem in its context, then it crashes mid-synthesis. You restart it, it starts fresh because the state was never really exported. Everything it found is gone. You have to start the whole investigation from scratch. On the right side is a coordinator that exports state periodically. Every time a significant milestone is reached, a sub-agent completes. A major finding is confirmed. A synthesis draft is produced. The coordinator writes a very structured state summary to a scratchpad file. Not the full conversation history, a summary of what has been found, what has been confirmed, what is still pending, what is the current working hypothesis. When the coordinator crashes and you start fresh, you pass this state summary into the new session context. The new session knows where the investigation was. It doesn't have to start from zero. This pattern is called structured state export, and it's how you make long-running multi-agent tasks resilient to crashes. It's a stage 5 technique in terms of where we teach this in detail, so you have to be hooked. But the seed is here in stage 3 because you need to design for it. When you build your multi-agent architecture, and you cannot just come back and be like, oh, I do not know this concept. So this is where we introduce you. Before we close this, look at the scenario diagram on screen, and I really feel that people who have been following along, this is the same diagram we have seen in and we've been building in since stage 1, video 1, and I want you to see how much it has grown. At the very bottom of the stack, the databases, the customer DB, order DB, exactly where they were in stage 1. Right? Connected via MCP, the stage 2's contribution is still there. So we have seen this, how stage 1 was a very simple system and how stage 2 brought in MCP, pre-hook, post-hook, etc. See, above the sub-agents came the coordinator, in which is new in stage 3. Larger than the sub-agent boxes because it is the orchestrator. Task tool arrows connect it to both agents. Labeled parallel, both sub-agents run simultaneously when the coordinator spawns them. The coordinator doesn't call get customer or look up order directly, it delegates, whereas that was not the case in stage 2 or stage 1. The small session ID label on the coordinator box represents what video 6 just covered. It manages session state, the state that can be resumed, forked, or start fresh depending on the situation. And at the top of all of it is the customer, arrow to the coordinator with the original query, or arrow back up with the synthesized response, and that is how stage 3 is complete. Multi-agent, parallel, failure resilient. When stage 4 arrives, the diagram stays as the base. We add Claude code configuration and the prompt engineering layer on top of what you will see now, and this diagram will turn out to be even more beautiful. Everything you built is still here, we just keep adding it step by step. So this video was all about sessions. How do you decide on whether you have to resume, if the state is intact, if the direction is approved. You can continue from pause point. Should you fork, keep valid prior work, change direction, original preserved. Should you start fresh, stale data, corrupted state, recollect from 0. So that's it, 6 videos. You now have the full stage 3 architecture. You have tons of walkthroughs to go through. You know when to go multi-agent and when to stay single. You know that contexts are isolated and the information must be explicitly passed. You know how the task tool spawns sub-agents and what a correct coordinator prompt looks like. You know when to use prompt chaining versus dynamic decomposition and how to design the exit condition for refinement. You know the difference between silent failure and cascade failure, how to prevent both, and how to manage sessions across long-running tasks, when to resume, when to fork, when to start fresh. So the stage 3 capstone builds the 3-agent research system: coordinator, account lookup, sub-agent, order lookup, sub-agent, all running in parallel. The source or attribution must survive to synthesis. Failures must produce coverage annotation. So do the walkthroughs first. When you come back for stage 4, I would really want you to come back. Stage 4 is where we expand to Claude code and prompt engineering. 2 more 20% exam domains, and I will see you there. All the best.